Good morning and welcome to Orkney International Science Festival 2024, Day 2. My name is Eric Walker and it's my pleasure to be hosting this event in the Picky. I was brought up on a diet of space race and the Apollo moon landings, so hosting this talk was a walk in the park for me. I had no problem putting my hand up for it. Our speaker this morning is Professor Mahesh Anand of the Open University. Mahesh is a Professor of Planetary Science and Exploration. He's a geologist by training and has spent the past decade researching the topic of water on the moon by examining rocks collected during the Apollo missions. He's passionate about sharing the knowledge and excitement of space exploration and engaging with creative minds to develop solutions for a more sustainable future. In his spare time, Mahesh enjoys travelling and growing fruits and vegetables in his garden. Not yet on the moon, though. He tells us it's 55 years since Neil Armstrong set foot on the moon, but few have followed and the dreams have faded. But now governments and companies are talking of a return to the moon, and it's being seen as a technology testbed for exploring Mars and the asteroids. Mahesh, over to yourself.
Thank you very much. You can hear me? Am I on? Yeah. Looks like, yeah. Okay. Thank you very much for that very kind introduction. And it has been an eventful past 24 hours. I started my journey here yesterday around the same time. So long story short, I'm here and I thank you for your patience because I'm half an hour late. And Neil Armstrong only had 30 seconds of fuel left before landing on the moon. And I'm sure that many in the audience would consider themselves child of Apollo. So you all know much more than I probably do about that historic moment. So I wasn't even born at that time. But what has followed in the previous 55 years has actually inspired a whole new generation to actually try to return to the moon. And isn't it amazing that even though we have landed humans safely on the moon more than 50 years ago, we still can't do that in a straightforward manner. So there must be a reason. And part of that reason is that we have been losing that knowledge and expertise over the years. And honestly, we have been actually missing that burning desire to further human presence in space. But it seems to be returning. And as often these things are, they are not purely driven by scientific or technological reasons. They are driven by often geopolitical situations. Which in this context, I would like to use it in a positive manner because it's good that there is a strong desire around the world now. There are many new spacefaring nations that I'm sure you have been hearing in news, such as China and India, who actually are trying to not just get to the moon, but even go beyond. So you may question why. You know, I started my life in India. I grew up in India for first 20 years before I started traveling around the world. And for the past 20 years, I have been based in Milton Keynes, if you know where Milton Keynes is. That's where the Open University is based. That's where our research laboratories are. And for the past 20 years, I have been trying to research those rock samples that were brought back by the Apollo astronauts, as well as many other types of rock samples from space that we have available. And before I forget, I have brought for you a piece of one such moon rock for you to come and inspect it closely and hold in your hand and ask any questions that you may have about. And also for those who may want to take a sticker or two home and share it around, we have come up with a theme called Living on the Moon. So when I came up with this slogan, my idea was not to send millions of people to the moon. That's not my vision is. My vision is that when this time we return humans to the moon, or even if we just return robots to the moon initially, it has to be done in a systematic and a sustainable manner, in such a way that actually you utilize the resources that are present at the lunar surface, and then you use those resources to actually sustain yourself there or go beyond. That's easier said than done. That means that we don't just need science. We need science, we need technology, but I would argue you need much more than that. You need a lot of other things like humanities, arts, social science, you name it. Basically, what we do in our day to day living. And that's why I'm really passionate to connect what we are trying to do with the lunar exploration with what we are doing here on Earth. Because if we can't connect the two, I think we will lose the purpose why we are going to the moon, right? So it's the sustainability at the end of it, but using the moon as probably a driving force, if that's what is needed to inspire the next generation, to engage people's creative talents from every direction, yeah, to make that possible. Because ultimately, we make those advancements and ultimately it will benefit the humanity. And it's a positive and a good thing to do rather than doing something that is not constructive. So let me just give you a little bit of background. You may already know about the Open University. If you don't know, then it is the largest university in the land. We have 170,000 students who are studying with us, either part-time or full-time. But aside from distance learning organization, we also do research. And that research is mainly done at our campus in Milton Keynes at Walton Hall. That's where I am based. And the Open University has been in existence since 1969, the same year that the Apollo 11 happened. So I say, two big things happened in the world that changed people's lives. One was, of course, that historic moment. And the other that is much closer to my heart as well is the inception of the Open City. Right? We do a lot of space research, and we are very fortunate to have an amazing standing in the world because of our involvement with a number of missions that are launched by the European Space Agency, NASA, and increasingly so other space agencies such as Japanese and the Indian and such. What we do is we do research into building instruments. And when I say building instrument, these instruments are very complicated. They're very complex, sophisticated instruments that usually occupy maybe a span beyond my hands, and they need to be miniaturized into this size. And that's a very tough job. But we have some wonderful colleagues who are actually very good at doing that. And that's what they've been doing for the past 40 years or so. And that has what led us to actually build and fly those instruments to various destinations. So you might have heard about the Rosetta mission. That's a spacecraft that actually went and chased a comet. It had a lander called Philae lander that tried to land on the comet, and the Open University had built an instrument that was on that lander. See on the left-hand side. We were also involved in a mission called Cassini-Huygens. That was a joint NASA-ESA mission to go to the Saturn's moon Titan. And we again had an instrument on that, and we are heavily involved in ExoMars. But on the top left, you see my colleague Simeon Barber. In his hand, he's holding that instrument that actually spans, twice my arm's length. Has been miniaturized, and that's into his palm of his hands. That is going to go to the moon in the next 3 years to make measurements for water ice. And he's leading that effort. So we are going back to the moon. Lots of other countries are going back to the moon. And I'm sure that there is nobody in this audience who hasn't heard about a recent lunar landing, one type or the other. There have been at least half a dozen landings that have been attempted in the last couple of years. And I will be telling you more about those. The good thing is that the moon is relatively close to us. In a direct trajectory, you can be there in less than 3 days. That's what the Apollo did. And many missions nowadays, they are trying new technology and things, so they take maybe longer, sometimes 6 months. But actually, you can reach the moon in less than 3 days. Communication delays just about a second or so. Compared to that, at the moment, it takes over 6 months to get to Mars. So let that sink in. 3 days versus 6 months, right? And then there is a communication delay of 10 plus minutes. So ultimately, the ambition is for humans to go to Mars, but it's not going to be that easy. So there are lots of technologies that need to be actually prepared, tested, and proven before we can contemplate, forget about humans, even sending higher cadence of mission to Mars, because half of the Martian missions so far have been unsuccessful because planetary bodies are very hostile bodies. They're not easy to land. It's one thing to leave the Earth's gravitational field. The other is to survive in the harsh radiation of space. And then finally, perhaps the most challenging part is actually get attracted by or get captured by the gravitational force of the body that you are targeting and then successfully land there. So there are many, many steps there which are full of challenges. So those techniques can be actually tested and tried on the moon. And that's why we think that the moon is going to be or is an enabler for exploring other destinations in the solar system. Now, just to put it into perspective, these are the locations on the moon, the 6 locations where at least human footprints are present even today. And these are 6 Apollo missions, the last of which happened in December 1972, the Apollo 17 missions. And since then, the humans haven't been back to the moon. And what you see on the left-hand side is what we see here from Earth. On a full moon day, that's what you see. That's the near side of the moon. On the right-hand side is what we call the far side of the moon. And that is something that was not seen until the Russian Luna mission actually sent back pictures in 1960s, very grainy pictures. And that's when it became obvious that the near side of the moon actually looks very different to the far side. And even today, till today, we are still not sure what is the reason. And that's why there are missions that actually are targeting the far side of the moon. And most recently, China's Chang'e 6 mission actually landed on the far side, first ever mission to land on the far side, and return samples from there. And right now, colleagues in China are actually analyzing those samples to find out what mystery it holds. Now, that's in grayscale. That's how we see the moon. But if you put the elevation on the moon in color, you will see those areas that look blue are sort of showing depressions below the zero datum. And you wouldn't be surprised to note that on the left-hand side, all those areas where Apollo missions landed, they were all kind of relatively shallow depressions or flat areas. These are called Marias. They're much easier to land. And on the near side, you have a direct connection to the Earth, of course. So it's much easier to actually have a mission. But on the far side, what you see, which we didn't know at that time, is that you have a huge mega basin. In that blue, that depth is more than 8 kilometers, deeper than the Mount Everest, right? And the size of that basin is more than 2,500 kilometers. That basin formed around 4.3 billion years, or even earlier than that. It is one of the biggest impact basins in the solar system. It's called South Pole Aitken Basin. And the name is a combination of South Pole because it's near the South Pole of the moon, and it goes all the way to the Aitken crater. So the two together encompass the whole range. So there is a tremendous amount of interest right now in understanding the origin of this basin and what might have happened to the moon at that time, and by extension to the Earth, because the moon has been Earth's constant companion for almost 4.5 billion years. So that's another thing why we want to explore the moon, is because the moon has been with the Earth since its beginning, and a lot of geological history on the Earth has been erased because of the tectonics, erosion, weathering, etc. Whereas on the moon, that history is still preserved to a large extent. So if the Earth and moon have been a companion all along for 4.5 billion years, and we want to understand the history of the Earth, moon is actually quite a good place to be looking for it. So that's another reason why we should explore the moon. Now, fast forward 55 years. This is a map up to date as of last month. And you see on the near side, so many other missions. So now you are looking at missions in addition to the Apollo, those that are robotic missions. And on the bottom, you see the far side, two far side missions, both by China. One was just a lander mission, which was a precursor to this sample return mission, which has just happened in the past few months. And in February of this year, you had Japan doing and demonstrating the most precise landing ever achieved on the moon robotically within a precision of 10 meters. Normally, the precision for landing is of the order of kilometers. So, even when Neil Armstrong and Buzz Aldrin were trying to land, they still had what is known as the landing ellipse of a kilometer or two. So for a robotic mission to actually demonstrate pinpoint landing within 10 meters is a major feat. And it's a very small mission. So actually the name itself suggests, even though it's an acronym, a SLIM mission is a smart lander for lunar missions. So you're going to see many more of these missions coming up because they are cheap, they are fast, and actually they can do much more than big missions. So there is going to be scope for both big and small missions. And on the right-hand side, you see a beautiful picture of the Apollo 17 crew. And you see on the left-hand side is Jack Schmitt, the only geologist who has actually walked on the moon. And I had a good fortune of actually meeting him many times and talking with him about the work that I have done on the samples that he has collected. And the Apollo 17 mission, and again, I might be preaching to the converted because you might know more history about this, now some of you, was a last of the Apollo mission. And by that time, the interest in the US public for going to the moon was dwindling or had already dwindled a lot. And this was the sixth mission. If 13 was successful, it would have been seventh mission, but of course, the 13 had to come back. It did majority of the science. So the previous missions before that didn't do as much science as Apollo 17 achieved, because by that time, actually, we had a better understanding of what we are seeing at the moon, what measurement we should be doing. And that space race had already been won by the US. So they were focusing much more on scientific things. So Apollo 17 achieved a lot of scientific outputs, which included doing measurements on the surface and then having, I would say that this is the first electric car that actually been driven on the moon, right? The lunar ranging vehicle. So the last three Apollo missions had these electric car on them. And they collected, most importantly for me, they collected samples from known locations. Because the meteorite that you're going to see later on, this moon rock, what we don't know is exactly where it has come from on the moon. But with the moon rocks, we know from the Apollo missions where they are coming from, because those are the astronauts who collected those samples. So there is a difference between the samples that were brought back by the Apollo astronauts and those that are present as meteorites. Both are telling us a lot about the science of the moon, but in a different manner. And if I have time, I can go into detail how one actually complements the other. So there is a space for both. Now, one of the biggest things that happened was for 40 years since the Apollo, there was a paradigm that said the moon is a desolate place. Of course, there is no life there, but also there is no air, no water. And so that way, it's not worth exploring in a way. But in 2008, around 2008, and that was the time when I was just starting my independent career, these orange soil samples were reanalyzed by some colleagues in the US, and we were also working at the OU. And with the modern day instrumentation, the developments that have happened over the past 40 years, and looking at it with a different perspective, we actually started to detect presence of hydrogen that was connected with oxygen. And you know that anytime you connect hydrogen with oxygen, you have water. So the whole field changed completely. All of a sudden, there was a realization that actually there is water present on the moon, not as a liquid flowing water that we know here on Earth, but the components of that water as hydrogen and oxygen does exist on the moon. And a whole new research field opened up in which we had a small contribution to make, which then led to this surge in interest in exploring the moon. And here you are seeing two pictures there taken on the lunar surface. Both are by Chang'e 5 and Chang'e 6 mission. Chang'e 5 mission returned some samples from the near side of the moon in December of 2020. So right in the, I would say, middle of the pandemic that the world didn't notice, but Chang'e 5 brought samples back, and that was first mission from China that brought any lunar samples. Again, I was fortunate to be invited to participate in some of their research, and we discovered again water in the same Chang'e 5 samples, along with Apollo samples and meteorites that we have been working on. And I'm looking forward to actually seeing results from Chang'e 6 and maybe one day have the opportunity to work on these samples myself. So while some water was being discovered in the samples themselves, there were satellites going around the moon, these new satellites that have been sent. And India's first mission to the moon, called Chandrayaan-1, was launched in 2008. And it had a spectrometer that could detect the presence of either hydroxyl, which is oxygen combined with hydrogen, or molecular water, H2O. And on the left-hand side, you actually see one such map that has been prepared based on that data. And all those blue colors actually represent the presence of hydroxyl near the lunar surface. So this was the second biggest thing that happened in 2000. So 2008, water was detected in the lunar samples. And around the same time, hydration features or presence of hydroxyl at the lunar surface was being detected by the Chandrayaan-1 mission, which had a NASA instrument called MQ. Fast forward, there were many other instruments that actually were sent, and they started detecting more and more presence of water, particularly near the lunar poles. So just like Earth's polar region, the poles of other planetary bodies in the solar system also seem to have higher abundances of water ice or presence of hydrogen. In case of the moon, the difference is that unlike the Earth, which is tilted at 23 degrees and a half, is the moon doesn't tilt as much. It barely tilts on its axis, so it's fairly straight. As a result of that, those deep craters that you have on the north and the south pole, they never see sunlight. And because they don't see the sunlight, the temperature in those craters are as low as negative 150 degrees Celsius or lower. Meaning that any water that actually gets in there gets preserved as water ice. And so at the moment, this is what is seen as the next gold rush. This is what the rest of the world is trying to get to, is to get to the lunar polar regions so that they can actually detect and measure how much of water ice is present. Why? Because water is the rocket fuel. Water is the most precious commodity in space. To launch a liter of water from Earth, it would cost up to $100,000. So if you can actually create your own liter of water at the lunar surface, you reduce the cost, you de-risk the mission, because then you are less likely to run out of water. And then you can use water for lots of other purposes. And you heard in the introduction that we haven't yet grown anything on the moon. Well, you need water to grow anything. So you have to first find the water, harvest the water before you think about doing anything afterwards. So once these remote sensing measurements started showing that there was some water ice present, NASA went one step further and say, how else can we confirm that the water is not just at the surface, it also goes below? So they did an experiment, it's called L-Cross mission, where they had a spent rocket stage, an empty rocket stage, that was impacted into one of these southern dark craters. And the plume then that actually came up was measured by a shepherding spacecraft that came after the impact, and it measured what was actually in that dust. And it did actually measure the presence of water. So it also confirmed that there is water not just at the surface, but also below the surface. What we don't know is exactly how far below it is and how far down it goes, how laterally, how far it is extending. So these are the questions that can only be addressed when we return systematically and actually do surveys. That's what we do here on Earth. When we are looking for new mineral deposits, when we are looking for new oil reservoirs, we do seismic surveys. We do lots of other geophysical surveys. We need to do those things on the moon as well to confirm some of these possibilities. And again, just over a couple of weeks ago, India was celebrating their first anniversary of successfully landing their Chandrayaan-3 lander at 69 degrees south. So at that point, India then became the only country that could land that far south. Most other missions had been restricted to plus or minus 20 or 30 degrees from the equator because it's very easy to land, or relatively easier to land. Whereas when you go further north and further south, it becomes harder because the terrain is much more rugged and the precision that you need to land is much, much higher. And the physics of landing also changes a bit because of the rotation of the moon and the motion of the moon in its orbit. But they were successful. And so on the anniversary of their first successful landing, they released the first data from their measurement, and it suggested that actually what they were measuring were reassuringly were very similar to what was revealed by some of the Apollo missions. So in a way, this was a trial landing. This was the first time. So they did not kit their lander with too many instruments. They just wanted to first demonstrate a safe landing. I'm pretty sure that in coming years, they are going to return to the same region and actually do further measurements or even bring samples back. Now, believe it or not, this one act, just like what Apollo did, enthused, excited, inspired a billion. You wouldn't believe everywhere after 23rd of August 2023 last year, every single festival in India, people are talking about the moon. Not for exploring the moon, but just using that success as a feel-good factor and doing something great with the talents that they have. There are outreach activities now happening in schools and colleges where young people are excited about STEM. They are excited about actually, thinking that, yes, I can also do it. And to me, that is really important. That's why I go around the country here whenever I get a chance. Last month, I organized an international conference in Dumfries. I brought in nearly 200 people from around the world who are lunar experts to Dumfries. You know what? Because in 2020, I was a lecturer for the Royal Scottish Geographical Society program called Inspiring People. And I was in Dumfries. And that evening, a lady came to me and said, "Did you know that this region had a connection with Neil Armstrong?" I said, "No. Can you please tell me a bit more about it?" And she said, "Yeah, not very far from here, there's a place called Langham, and that's the seat of Clan Armstrong. You should visit." I said, "You bet." The next morning, I packed my bag. I knocked at the door of the Ginlocky Tower. That's where they have the Armstrong Museum. I met a fantastic colleague, Ian, and I said, "Ian, I'm here, I'm so and so, and I really didn't know. Can you tell me more about it?" And what I learned was that non-scientific community actually knows more about it than the science community. Because Ian was telling me that it's a huge tourist attraction. Lots of people from America, actually, they visit that place to explore that connection. I said, "Ian, I want to bring this to the science community. I want to bring the world to Dumfries to see that," right? So I did a bit more research, and I found that the Clan Armstrong itself had a very interesting history. Again, I'm just sharing with you what excited me. You probably already know, but Armstrong clan were part of what was known as reavers. Who were reavers? They were people who were actually stealing and snatching and looting things from other tribes. And the funny thing was that they apparently used a flag. On one side, it would have English flag, on the other side, a Scottish flag. So depending upon who they were fighting, they would use that flag. I said, fantastic. Think about it. The first human on the moon. Could you have imagined anybody better who had that perseverance to actually land on the moon than somebody coming from a river clan? I think there was something in Armstrong's blood. I use that to actually, bring a bit of excitement. But my point is that 500 years ago, nobody in that community would have known that perhaps some descendant long way down could be the first human on the moon. So how do we know in this room that we cannot be one of those people? Who can stop us? Just ourselves. Yeah. And this is why I brought people in, and then I broke the conference for a day and I said, you all are going to go and visit Langham and learn about the history. Yeah. They did. They were fascinated by it. Yeah? And it's wonderful. And you never know how many new ideas have come up to do more projects. We worked with 100 local people in Dumfries and Galloway area. We brought them to the venue and we actually showed them what we are doing. Yeah? Those kids might have never actually seen this, but now they are taking part in a number of projects with us. Huh? And if only one or two of them that I got in touch with, out of those 100 actually remember 10 years down the line that was the event that actually put me to this path, I'm happy. Yeah? One change, one life at a time. So I digress. But there we go. So what we need to do is, what I'm trying to emphasize is, please do not take it as we are just in a mad rush to go to the moon because we love to explore the moon. Maybe some do. And I am part of it. But my proposition to all of you is, let's use this in such a way that actually that brings some benefit to the society, and a benefit that we all can be part of, we all can share. And I'm quite happy with the Artemis Accords that is coming up, because NASA obviously, again, it partly is geopolitical, but put that aside. See what's good in it. So Artemis is trying to bring different countries together and say, let's explore space together. In this instance, the moon, and then beyond, right? So there are now 40 plus countries that have actually signed up to Artemis Accord. Artemis was the twin sister of Apollo, so it's no coincidence that the program is called Artemis after Apollo. And Artemis is where actually the next generation is going to play a big role, where we are not just going to the lunar surface again, but we are also going to be putting some sort of a space station type of setup around the moon, so that you don't have to be at the lunar surface all the time, because the surface of the moon is very hostile. You cannot be there all the time, or if you want to be there, you have to be there with proper protection and in habitat, etc. So until we sort all those things out, you can be in a space station-like setup where actually it can be in an intermediate post, and you get access to the moon while you are there, and then you bring astronauts back up. Or maybe you don't need astronauts. You can still do things robotically with astronauts in the space station and the robots on the lunar surface. Time will tell. That brings me to a question of the resources, because remember, I was telling you right at the start, to me, it's more about sustainability. It's more about connecting how you use your advancement in technology here on Earth for application on the moon. And once you develop something for the moon, you then bring it back to Earth. So it has to be a complementary process in a cyclic manner. So what is there on the moon as a resource? Well, we just identified that maybe there is a lot of water on the moon. That's a huge resource, not to bring it to the Earth, but actually use it for human consumption or other purposes at the lunar surface, which means you don't have to bring your water from the Earth. What else is there? Now, There is a lot of talk going on about recycling and how much waste we generate and everything. We should be talking about zero waste approach. Nothing is a waste. Yeah? What we call waste could be somebody else's resource. Now, moon being a challenging place actually forces us to think more along those terms that here on Earth. We are very rich here on Earth with resources. We don't think how else we can use something. But on the moon, you have no choice. What you carry in your backpack is what you're going to survive for some time. So if you don't start making use of the resources that are there, and 100% of them, yeah, you're not going to be very sustainable. And the other resource, other than water on the moon, is the lunar soil itself. Yeah? Lunar soil has everything that we need, almost everything that we need, believe it or not. Because everything that we use in our daily life is derived from rocks. That's another thing that actually some of our younger generation actually need to appreciate a bit more, is the where stuff comes from. It's all derived from rocks. It's all geology, right? So at the moon, we have got the lunar soil. And what is lunar soil? It's simply a mixture of a range of elements. Those elements that actually give us, metals, or even those we call volatiles. You can have gases that you can produce. Everything is present in the lunar soil, one way or the other. The question is, are we able to extract it? Can we extract it? So that's where a lot of research is currently going. And that brings me to the question, do we consider the lunar dust as an asset, or is it a liability? Because in one sense, it's a liability, because when astronauts actually went there, they complained things getting clogged because of the lunar dust. Their vehicles were actually getting stopped, and the dust was getting in everywhere. So dust can be actually problematic. We know that for breathing, dust, you don't want to breathe dust. But at the same time, that dust has everything that we need to extract our resources. So it can be a liability, but we can convert it into an asset. But we need to do work. And that's where, again, our research comes in. So at the Open University, we do research on a range and types of samples, all the way from solid rocks to a small dust that only the most powerful microscopes in the world can see. Our naked eye cannot see. It's 100 times, 1,000 times actually smaller than the width of a hair. Yeah? But we have those instruments at the Open University and many other places around the country and the world, which we use to understand the nature and character of it, to actually derive scientific knowledge. At the same time, also knowledge that could be useful for future technological applications. Now, in this case, it's an example of a scientific knowledge that we gained by analyzing rocks for their water content. And we figured out currently what we know about the moon, where the water might have come from. So some could have come from comets that could have actually impacted the moon. Some could have come from asteroids that could have impacted the moon. Some could have even come from the Earth itself when the moon formed. Because there is a theory that's the most it's the most widespread theory at the moment, which is accepted in the community, that the moon actually came from the Earth itself. There was a giant impact that expunged a lot of material, which subsequently formed the moon. So the moon is no different than the Earth. It's the geological evolution for the following 4.5 billion years that has changed what we see on Earth versus what we see on the moon. So we do all that, but we need to get to the moon. Until we have a more permanent human presence on the moon, what we can do is we can send missions with landers, with rovers, and robotic capabilities. And one of those missions that is now slated, only last week there was an announcement that NASA has just given a contract to a company called Intuitive Machines that demonstrated the first successful landing at now the most southerly point on the moon, almost close to the lunar south pole. They did earlier this year. That was the first demonstration. In 2027, they are going to launch a mission, which it will have an equipment built at the Open University, which will have a drill that will go up to 1 meter, collect samples, and it will be analyzed in a lab. It's an analytical lab called Prosper, which is what we are building. It's what I showed you my colleague right at the start. They are building that will do the analysis of those soil samples to confirm how much water, how much carbon, how much hydrogen or nitrogen is there. So we can build on to that. So we are really looking forward to that. Then fast forward, we need to build habitats. So either you find natural habitats, and here at Orkney, I don't need to tell you habitats because we are in Neolithic historical region, right? Because humans started their life in caves, in stone-built habitats. We can build the same thing on the moon, right? So I think places like these can be hugely inspirational for the work actually that can be done, for the type of sites and the locations that can be actually explored. And one such example that, again, you might have seen in the press, that caves have been found on the moon. So this was a report that came out a couple of months ago, where actually a radar was used to look through what is called a skylight. So these are the openings in the lunar surface, so where collapse has happened into previously existing lava flow, and you can actually see through it through radar to see how deep these things are. And that's an artist's rendition. As you can see, these are about 100 to 150 meters deep, and they probably go further in. We don't know how far in it goes because radar can only see, as you see, where the red patch is going. But it could be a potential site for future human habitat. Lots of technological difficulties. How do you get in 100-meter deep hole, and then how do you come out? All sorts of things. But at least what this is illustrating is there are locations, natural locations that can be used as habitats. And while you are going down, you see these layers that they are showing. They are also layers of lavas that have erupted over time. So if you're interested in understanding how the moon has evolved, you need to bring samples back from those and analyze them in the labs. So while actually doing your habitat exploration, you're also supporting scientific investigation. If you don't have natural habitat, you can build your own. In the middle part, you see at the bottom an artist's impression. This is by the European Space Agency of what a future habitat on the moon look like. Right? And for that, we are exploring the possibility of doing 3D printing. So building of structures using 3D. But what will we use for 3D printing? Because we don't have cement on the moon, or even if we have cement, it will require a lot of water, which we don't have. So we are trialing a new technique. What we are trying to do is actually use microwave energy. And at the top, you see equipment that we have actually custom built. It's nothing but a standard microwave that we all have in our kitchens. Yeah, but it's just a slightly higher grade, so it can actually hold things at higher temperature for much longer. We have been actually melting in the middle bit. What you have is a lunar simulant, so a material that has very close similarity to what we think is the lunar soil, has been put through that microwave and has been heated to a temperature of close to 1300 degrees Celsius, 1400 degrees Celsius. That's what you see, those red bits. They are like molten lava. Within 10 minutes, that microwave actually melts that. So what we want to do is actually, after melting this, we want to use 3D printing to then 3D print structures to make your solid structure. So there's no cement, no water, nothing involved. You use the microwave to heat up the lunar soil, you melt, and then you pass it to a 3D printing nozzle to create your own structure. And that caught the eye of the BBC, and they came and they visited and said, oh, okay, Open University scientists are testing moon dust for water, because what we also want to do, when that heating is happening, any water present is going to be released. You don't want to lose that. We are capturing that water as well, right? So multiple things. That's why I am saying it's a zero waste approach, because and I will show you a couple more examples of what happens. So imagine you have powdered rock. It will have everything in it. different elements, different oxides, maybe some hydrogen, maybe some carbon. You heat it up. You heat it up all the way up to where it melts. In between where you started and time where it melts, you are going to release different type of things, different gases, different elements. If you have the ability to extract different things at different times, you're not wasting anything. Yeah? And ultimately what we need after water is what we breathe, oxygen. Half of the moon rocks, half of the lunar soil, half of the earth is oxygen. That oxygen on the moon is bound in rocks. On Earth, we are lucky that a lot of it is bound in rocks and minerals, but a lot is also present as free oxygen in the air which we breathe. Yeah? But it wasn't always the case. Yeah? So we shouldn't take it given on Earth we always had oxygen. No. We didn't begin our history on Earth with oxygen. It came out through volcanoes. It then was released, and because of the gravitational field, the atmosphere then developed, which then became rich in oxygen. On the moon, that oxygen is not there. There is no atmosphere, so you need to extract your own oxygen. But if you can extract water, the next obvious step is to split that water to make your oxygen. It's not that difficult. Yeah? And if your lunar soil is 50% oxygen, then you can get a kilogram, and half a kilogram of it should be oxygen. So we are trialing the use of microwave energy and other techniques to produce water, oxygen, and eventually to use this for building shelter. That's quite a long research project. It's not quite straightforward at the moment how we will do it, but we are making progress. But I want to bring you back to Earth. As I said, I want to have one foot on the Earth, because anything I'm doing for the moon is with the issues and challenges we are facing on Earth in the back of my mind, or rather always at the forefront. How can we use these technologies, which we are not forced to develop here on Earth, but for the moon? And once we have developed it, why don't we actually apply it immediately? So here I'm showing you an example of an idea that came to us where we said in North Wales, so I don't know if you know, but the Isle of Anglesey, northwestern part of Wales, used to be the biggest producer of copper in the world 200 years ago. Now, copper demand went down, but now the copper demand is going up like that, right? And two biggest copper deposits in the world, one is in Chile and the other is somewhere in China, right? So, but we are sitting on a huge amount of copper in this country. Where? In those mine dumps. Because 200 years ago, we actually took all the best copper that we could find, and we didn't care about those that were present in lower amount because we didn't need them. What did we do? We made a big mound, mine waste. It's sitting there, 200 years. That landscape in Anglesey, it looks like as if you're on surface of Mars, literally. Yeah? And it's nothing but what is so-called waste. We went there, we collected the sample, and we put it through the microwave system. And you can see how hot this is getting. This is getting over 1,000 degrees Celsius. That's the end product. When we did the analysis, what we found was all that copper that was discarded as being not present in, good enough amount to be extracted as a ore, has come together to make bigger beads. All of a sudden, it's of interest. So if we can use our technology that we are developing for lunar application for processing mine waste, A, you are reducing the mine waste, and B, you are potentially going to extract something meaningful from that mine waste for some good purpose. Yeah? That, to me, is what we should all be trying to do. All the scientists, because I did not set out to work in the mine business. It's just because I was forced to develop something for lunar application is why I came up with the idea. And now I'm focusing my attention on doing this research because this can benefit us closer to home, right? And on this slide, you see two directions in which you can go. One, on the right-hand side, is where the ore, a good bit, maybe 5%, maybe less than 5% is taken out, 95% is thrown out as a mine dump. You can actually reprocess the thing with a conventional heating process and all that. And we have just used some of that mine waste to do 3D printing and produce Lego-like bricks, just to demonstrate that you can actually create structures using that same mine waste. Huh? On the left-hand side is what started with the lunar application. You microwave it, you take out all your essentials like hydrogen, carbon, oxygen, metals, whatever you want, because on the moon you need those. Whatever is left, you can again do 3D printing. So it can help with the lunar exploration, and it can help with the regreening and cleaning the environment here on Earth. This stage is very conceptual. I have no doubt in 10 years' time, this will be picked up by the industry and this will be more commonplace because there is an economic argument. Okay. And you mentioned about growing plants in the moon. So yes, I do grow my own vegetables and fruits in the garden along with flowers. I like flowers too, but I have just created a patch to see whether can I grow something that I can, survive on. And I'm waiting for my corn when I go back. So it's coming up. Well, in the meantime, there was an eruption in La Palma in 2021. So La Palma is an active volcano. And in September 21, there was a big eruption and it was a lot of damage. Once again, in the news, everywhere it was showing. You would remember the Icelandic eruption that caused all the disruption for transport and all. But La Palma actually covered lots of houses and banana plantation and all got destroyed. One of my colleagues, he brought some ash from that volcano back. And I said, and he's Alan Butcher, he used to work at the Finnish Geological Survey in Helsinki. Somehow we got connected through another colleague. And I said to Alan, this ash looks so much like the lunar soil. How about if you did the experiment of actually mixing this ash with some compost to see can we grow some plants? Because on the moon, you cannot carry 100% compost. But even if you carry a kilogram of compost, if you can use a little bit of it to mix it with the lunar soil to grow something, it will go a long way compared to using your 100% compost. Okay, so what do? So one summer, this was 2 summers ago, we sat down in our garden and I made a mixture. It's a 10% ash, 50% ash, 75% ash, the rest compost. And I said, I will do an experiment and I'll call it green rockets for the moon. Because I was planning to grow rockets. They are green, and green rockets sound good for the moon too. Yeah, we did it. We grew it. Yeah, it was wonderful. For 50 days, I meticulously day and afternoon, I actually made notes in the notebook, temperature and how it was growing and all that. And we then published a small paper on the back of it. And I also collected those leaves because I wanted to analyze them under X-ray to see what was it that they were uptaking in those ash, where you had 75% ash compared to the 25% ash. What was the difference in their uptake? And we found difference. Probably lighting is not good enough, but you can see that there's a difference in 75% ash and 100% compost experiment, where the uptake of phosphorus, which you need for plant growth, is different, where actually it is more in compost than in the ash. But growth is still happening. So it was really a fun bit. I mean, I really just enjoyed doing it. What came out of it is a learning, of course, and then we are now actually going forward. And some of these things do get picked up sometimes by media. So we had some of you might recognize Dara. So Dara visited the OU and fascinated by the work that we were doing. And there is a Channel 5 documentary, 2-part, called Wonders of the Moon with Dara O'Brien. If you would like to see that, he covers much of our work in probably a much more simpler manner than I'm able to convey to you. You will enjoy it. So not only that, then suddenly Chemistry World picked up on that and said, oh yeah, there is a race to build base on the moon. And they said, okay, we want to talk to you about that. And then said, okay, now we need to also convey to the stakeholders that it is not a race and it is not doing things irresponsibly. So you have to do responsible exploration in a sustainable manner. And that's why we need to manage. We need to manage. We need to make a recommendation. We need to work with international organizations that shouldn't become, unregulated activity. Even though it is so far, there is a chance that actually it could potentially harm the natural environment. So there has to be a balance. That all needs to be thought through. And as we look forward, this is the new rocket that NASA is developing, called the Space Launch System, SLS. That was on its launch pad that successfully launched the first trial, where the capsule, this is the one that is going to carry the next generation of astronauts to the moon. It went on its first journey, and here it has taken a selfie of itself with the moon in the foreground and the Earth in the background. Probably one of the most beautiful pictures after the blue marble that we are seeing. Now we are looking from a different vantage point. Yeah. So it was on the Apollo 8. Of course, you would remember the famous Earthrise picture that captured everybody's imagination, that all the life that we knew in the universe was in that one picture. Yeah. So, and then here are some of the colleagues who will be hopefully going to the moon. So on the left-hand side are 4 selected astronauts by NASA for the Artemis 2 crew. And on the bottom right, you have got the 3 new UK astronauts. One is in commission. John McFall is the first person who is training to become the first astronaut to go to space who has a disability. And McGann on the bottom right is a reserve astronaut who might actually get a chance through some other mission. So at the moment, these are our UK astronauts, and at the top are our latest ESA astronaut, the European Space Agency astronaut. So I come back to my original theme, and as you know, I've got some stickers called Living on the Moon. This was in 2019 on 50th anniversary of the Apollo 11. I put together a consortium of universities in the UK to share what we were doing together for exploring the moon as a Royal Society Summer Science Exhibition in London. We had thousands of people there, lots of children come in. And I was just fantastic. And it's sometimes low tech and sometimes high tech. Yeah, so we use everything that is at our disposal. Sometimes you can just use a globe to engage a young mind. Yeah, they start asking questions, and sometimes you can actually give them a virtual reality. And nowadays, anybody can walk on the moon putting a virtual reality. And it is as a result of the missions that have actually imaged the moon in such unprecedented detail that we are able to reproduce that reality experience. And of course, on the right-hand side, somebody is very proud to show them the Apollo discs that has got the actual Apollo samples from the. So I think I have taken enough of your time. I would like to think that we are, a spacefaring species. We are moonbound, but we mustn't forget that we live here on a beautiful planet, and whatever we do out in space has got immediate relevance to space, to Earth. And this picture again caught my attention. This was, I think, one. I forgot to write the credit. I should correct that. But this was a picture, I think, was in Nature, where after the Chandrayaan landing, the excitement that was actually captured in one of the events in India, and they were commenting on that. So once again, it's not just about the moon; it is about inspiring the next generation, and giving them that empowerment that they feel that they can do whatever they want. But it's up to them. It's their decision. So thank you so much for your attention, and I will put this one up again. So you can, yes. So,
That was quite a talk. Your passion and your enthusiasm for your subject is it's infectious, right? So it was wonderful. I was absolutely hooked on this. They were really tight for time. So I'm going to take one question from the audience. We have a room aside up there, so we can actually, after this,
yeah,
we can go up there and we can talk directly with yourself, Mahesh,
yeah,
and really get into the depths, if that's okay with you.
I'm at your disposal.
Yeah.
Yeah.
So I'll take one question. Paul, I've got Paul down the front here.
Thank you for a super presentation. Really good. We know from experience of the ISS that long-term exposure to microgravity is bad for the human frame. To what extent have we knowledge of how the human frame might survive in moon gravity?
Great question. I mean, the answer to this can be very short or very long, because the short is that we just haven't done that experiment, because we have to be there at the lunar surface for long enough period of time to see the difference that the maximum we have spent is few days, right, in the Apollo mission. And since then, we have not even sent humans into that far out. Yeah, but one could argue that for space microgravity, ISS is good enough to give us an indication as to what's happening. Really, we need to land on the moon and be there for extended periods of time to do that experiment. But if we want to interpolate between the two, microgravity versus 1G here on Earth, we are 1/6 on the moon. So anything that we have learned from ISS, it should be somewhere between that and the Earth. I mean, that's what my educated guess at the moment is, without any hard data. But I think there are bigger problems than just the gravity, as you know, is radiation on the moon. There are other challenges, such as, surviving on a life support system that also we need to take. So I think when we consider all of those things together, and that's why there's a huge debate in the community, that do we need humans on the moon? Can we actually do everything robotically, right? It's not easy to answer that question. And maybe for some of the things, humans are still essential, are useful. If for nothing else, it's for inspirational thing that, one human being on the moon could bring that maybe 100 robots won't. But maybe times are changing. Yeah. So we will see. So I don't, as I said, it can be a very long answer, but from ISS, whatever we have learned is at least humans are returning. So now the longest time is spent is several hundred days by an astronaut on ISS, and they are still around. They are still not showing any big signs of bad impact on their health. I mean, we know the bones and muscle loss and things that do happen, but it's not so adverse that we have to stop exploring. So time will tell.
Right, I'm just going to do a little bit of festival housekeeping, and then we'll head up to that room, and I'm sure we're going to have quite a few discussions along these lines. Right, coming up next, we have here in the Phoenix Cinema at 2 p.m, we've got Professor Jim Flett Wilson talking about Viking genes, genomic medicine. Now, this is sure to be well attended. I think I learned that there's a couple of hundred people already booked, so there'll be other folk wandering. So if you want to get a seat, get in early. I think that's the best advice. We hope you're enjoying the festival, so don't forget to like us on the multitude of social media we have now. And we'd also like you, before you leave, or what's the question? Sorry. You'll need, if you could fill in a feedback form for us, it helps us improve the festival all the time. And to give you a little bit of motivation, if you fill in the feedback form, you can be entered into a draw for £100 worth of Northlink ferry vouchers. So there you go. Also for festival goers, there's a 10% discount on the distillery shop or the cafe in the Orkney distillery, the gin distillery just along the road. You just wave your ticket at them and you'll get your discount. So once again, Mahesh, thank you very much for absolutely stimulating talk. And I'm really looking forward to having a chat with you up in the room. So if we could thank Mahesh.
Thank you.